is equal to, 3 cos x minus 25 plus 2 is equal to 0. Solve as follows. Okay, so how do we do this one? Well, we can say, let's try and get this into that first form. Trigonometric ratio with a given angle equal to some constant, right? And so that's simple, because I can take this 2 over, or subtract 2 from both sides, and I get minus 2. And then I've got cos of x minus 25 degrees, right? Let's just fix that handwriting a little bit. X minus 25 degrees is equal to minus 3, right? 3 cos x minus 25. Then let's divide both sides by 3. And I've got now cos of x minus 25 is equal to negative 2 over 3. Right. Now, when finding the acute angle, we ignore the negative sign because the negative only tells us which quadrants we have to reduce it with. So using our QRS method, I'm going to start with the quadrants. Since cos was negative over here, I'm interested in the second and the third quadrant, right? Because cos is negative. And now for the reference angle, I need to solve for it. So how do I do that? I'm going to say that x minus 25 degrees, right, is equal to second function cos, and I just need to use the positive version of this, and then I get what the reference angle should be. So let's do that on a calculator. We type in second function, which is represented by the shift button in the corner, of cos of 2 over 3. Right, so that's what you want to type in. Something that looks like that. Press the equal to sign and we see I've got 48,19. Right. So I'm going to round that off only to one decimal point for now. So that's 48,2. Remember, you need to follow instructions. If your papers say 2 decimals, use 2. If they say 1 decimal, use 1. Okay. So this now, what I've received over here is my reference angle. Okay. So that solves R. R is my reference angle, which is 48,2 degrees. Okay. Now we need to solve, which is what we use S for, Q, R, and S. For solving, I need to solve in the second quadrant first. So I'm going to say the given angle, which is this thing over here, x minus 25 degrees, is equal to the reduction formula approach, and that's going to be in the second quadrant, 180 degrees minus theta, which is the reference angle, 48,2 degrees for now, plus n multiplied by 360 degrees. And why do I say 360? Because I'm working with cos. Okay, so now I can solve for x. I'm going to say that minus that and bring this over. So it's going to be 180 minus 48.2 is going to give me 131.8 plus 25 degrees gives me 156.8 degrees. Plus n times 360 degrees, nothing to divide here, and therefore n is an element of the integers. Right? Now let's solve for the third quadrant on this side. And when I solve for the third quadrant, let's do it in black. I'm going to say again x minus 25 degrees is equal to the third quadrant's reduction formula, which is going to be 180 degrees plus the reference angle, which is 48,2 degrees. And let's simplify that. 180 plus 48.2 is 228.2 plus 25. And that's going to give me 253 degrees, comma 2. Right, plus n multiplied by 360. I'm supposed to have that here as well. And then at the end, I can state the restriction such that n must be an element of the integers. Now again, these are all examples of grade 11 questions, which are of course also relevant for grade 12. Right? I will also be looking a little bit later at examples that are particularly relevant for grade 12 only.